There's a metal you've probably never heard of sitting inside almost every phone, router, and radar system on the planet. And right now, its price has gone up by over 120% in just over a year. Not because of a shortage in the ground, because one country decided to close the tap, and that country happens to control almost the entire global supply. That metal is gallium, and what's happening to it right now might be the clearest sign yet that the chip war between the West and China has entered a completely new phase. If you care about where technology is actually heading, not just the headlines, this is exactly the kind of story we break down on this channel. So make sure you're subscribed before we get into it. Let's start with what gallium actually is, because most people outside the semiconductor world have never even heard the name. It's a soft, silvery metal, and on its own it doesn't look like much. It even melts in your hand at room temperature if you hold it long enough. But combine it with nitrogen or arsenic, and you get two of the most important materials in modern electronics, gallium nitride and gallium arsenide. These two compounds show up in places you'd never expect. They're inside the power supply charging your laptop right now. They're inside the radio chips powering your Wi-Fi router. They're inside 5G base stations, military radar systems, electric vehicle chargers, and satellite solar cells. Gallium. Nitride in particular has become the go-to material for fast, efficient power conversion, which is exactly why it's spreading into everything from phone chargers to the massive power systems inside AI data centers. Even the electric vehicle industry has quietly become dependent on this one obscure metal. A few years ago, gallium nitride components barely existed in EV platforms. Now, they're showing up in roughly a third to nearly half of new vehicle designs for major manufacturers, because GaN power electronics let cars charge faster and run more efficiently. Nobody buying an EV thinks about gallium for a second, yet it's quietly become one of the materials making modern electric vehicles actually work as advertised. Here's the part that should genuinely concern anyone paying attention to global supply chains. China controls somewhere around 98% of the world's primary gallium production. Not 60%, not 70%, basically all of it. For decades, the West simply didn't need to worry about where this metal came from because it was cheap, abundant, and nobody thought to question the supply chain behind it. That comfort ended in December 2024 when China imposed a full-scale export ban on gallium, germanium, antimony, and several other critical materials, specifically targeting the United States. This wasn't a subtle policy tweak. It was a direct, deliberate move in response to Western restrictions on advanced chip-making equipment and technology exports to China. In other words, this is retaliation, and gallium became one of the sharpest weapons available. What makes this leverage so effective is how quietly it built up over decades. Gallium was never treated as a strategic resource the way oil or lithium were. It was simply a byproduct of aluminum and zinc processing, cheap and abundant enough that nobody in the West bothered building alternative extraction capacity. China, meanwhile, invested heavily in refining this exact material for years, until it effectively became the only serious supplier left standing. By the time anyone in Washington or Brussels realized how concentrated that supply chain had become, China already held nearly all the cards. And if you're finding this breakdown useful so far, drop a like on the video. It genuinely helps this channel reach more people trying to understand the real forces shaping the tech industry. Now let's talk about what actually happened to the price, because the numbers here are staggering. Before these restrictions escalated, gallium was trading at a few $100s per kilogram. By early 2026, prices outside China had rocketed to roughly $2,100 per kilogram, a jump of about 123% since the start of the previous year alone. And that's not even the full story, because earlier rounds of restrictions, going back to 2023, had already pushed prices up by double-digit percentages multiple times before this latest surge even began. To put that in perspective, imagine a raw material your entire industry depends on, suddenly costing more than 20 times what it did just a few years ago, with no guarantee it gets any cheaper. That's not a normal market fluctuation. That's the direct result of a single country closing off the tap on a resource nobody else can easily replace. Gallium isn't even the only material telling this story. Germanium, another metal China, dominates and often controls alongside gallium in these same export restrictions, saw its own price rocket from around $2,800 per kilogram in early 2024 to well over $8,000 per kilogram by early 2026, a surge of more than 200%. Germanium happens to be essential for fiber optic cables, and modern AI server racks use staggering amounts of fiber, sometimes over 1,000 individual fiber connections in a single high-density rack. When the material behind that fiber suddenly triples in cost, the impact quietly ripples straight into the AI infrastructure boom everyone's been talking about. The ripple effects go far beyond gallium itself. Around the same period, tensions in other parts of the world compounded the problem further, disrupting shipping routes and supply chains for related chip-making materials, and at the exact same time gallium was already tightening. When multiple critical inputs get squeezed simultaneously, chipmakers don't just face higher costs, they face genuine uncertainty about whether they can secure enough material to keep production lines running at all. This is where the phrase priced out starts to make real sense. For smaller chip manufacturers, especially those producing power semiconductors and RF components on tighter margins, a price increase this extreme isn't just painful, it can be existential. Larger companies can absorb the shock for a while by eating into margins or passing costs onto customers. Smaller players often can't, and some are already being forced to rethink entire product lines built around gallium-based components. Some manufacturers are quietly redesigning products to use less gallium nitride than before, substituting older, less efficient materials just to keep costs manageable, even though that means shipping slightly worse products than the market actually wants. Others are simply raising prices and hoping customers don't notice or don't have a better alternative. Neither option is a real fix. Both are just ways of buying time while everyone waits to see whether this supply crunch eases or gets worse. Defense contractors are watching this especially closely, and for good reason. Gallium nitride is a core material in military radar systems and advanced communications equipment. When a supply chain this critical to national defense runs almost entirely through a single geopolitical rival, that's not just an economic vulnerability. It's treated as a genuine national security concern at the highest levels of government. Some governments have responded by building strategic stockpiles, specifically for defense applications, holding reserves meant to cushion the military supply chain even if commercial supply dries up completely. But those stockpiles are typically modest, often covering only a matter of months of consumption rather than years, which means they buy time rather than solve the underlying dependency. It's a stopgap, not a strategy. And most officials involved in these programs will admit that privately, even while defending the approach publicly. So what has the West actually done in response? A few things, and none of them are quick fixes. Companies have started stockpiling gallium despite the eye-watering carrying costs, sometimes estimated at 15 to 25% annually for holding high-value semiconductor materials in reserve. Governments have begun funding domestic gallium recovery efforts, pulling small amounts from aluminum and zinc production byproducts, though these processes are nowhere near efficient enough yet to replace what China supplies at scale. There's also a growing push toward recycling gallium from electronic waste and manufacturing scrap, alongside long-term research into alternative materials that could reduce dependency altogether. But here's the uncomfortable truth. Building an entirely new domestic supply chain for a critical mineral doesn't happen in months. It takes years, sometimes over a decade, of investment, permitting, and infrastructure development, and China had a multi-decade head start. Some governments have gone further, signing long-term supply deals with mining companies outside China, and even taking direct financial stakes in rare earth and critical mineral producers just to guarantee future access. These deals often come with price floors and multi-year offtake commitments, essentially governments betting billions of dollars that reducing dependency on China is worth paying a premium for right now. It's an expensive insurance policy, but after watching prices spike over 100% in a single year, more governments are deciding that insurance is worth the cost. Interestingly, this story hasn't stayed static. At various points, China has actually eased these restrictions temporarily as part of broader trade negotiations, suspending certain export controls for limited windows before letting them potentially snap back into place. That on-again, off-again pattern creates its own kind of chaos for manufacturers trying to plan years ahead, because nobody can be fully confident the tap won't close again the moment negotiations sour. This uncertainty is arguably just as damaging as the price increases themselves. Businesses hate unpredictability more than they hate high costs, because at least high costs can be planned around. And when a critical material's geopolitical relations between two superpowers, every long-term investment decision becomes a gamble. Imagine trying to plan a 5-year product roadmap for a power semiconductor line when you genuinely don't know if your core raw material will be available, restricted, or 3 times more expensive by the time you actually ship. That's the exact position chip executives find themselves in right now, and it's pushing many of them toward decisions that wouldn't have made financial sense at all just a few years ago, like paying a premium for material sourced anywhere other than China, simply for the certainty of supply. Zooming out, gallium is really just one piece of a much bigger picture. China has similarly tightened control over other critical materials tied to chip making and defense technology, including rare earth elements essential for everything from semiconductor manufacturing equipment to the networking gear running today's AI data centers. Analysts have estimated that these combined restrictions have already reduced global semiconductor supply capacity by somewhere around 18 to 22%, a number that would have sounded absurd just a few years ago. What we're really watching unfold here is the slow, deliberate weaponization of the periodic table. For decades, global trade assumed raw materials would flow freely because that's simply how modern economies function efficiently. China has demonstrated, repeatedly now, that it's willing to use its dominance over these unglamorous, easily overlooked materials as genuine geopolitical leverage without needing to touch a single trade agreement or tariff schedule. And the West is only now waking up to just how deep that dependency runs. It's easy to focus on flashy chip export bans and headline-grabbing sanctions on advanced processors. It's much harder to notice that the raw materials feeding the entire industry were vulnerable the whole time, quietly controlled by a single supplier most people never thought to question. This pattern isn't limited to gallium and germanium either. Rare earth elements essential for semiconductor manufacturing equipment, magnets, and the networking hardware running today's AI data centers have followed a strikingly similar path. China has, at various points, restricted shipments of elements like dysprosium, terbium, and yttrium to specific countries almost entirely, sometimes recording literally 0 shipments for months at a stretch. When you line all these restrictions up side by side, a clear strategy starts to emerge, one focused less on any single material and more on maintaining leverage across the entire technology supply chain at once. So where does this leave the chip industry going forward? Prices for gallium and related materials are likely to stay elevated and volatile for years, not months. Companies that depend on gallium nitride and gallium arsenide components will keep facing pressure on margins, product timelines, and long-term planning, at least until alternative supply chains mature enough to genuinely compete. Some analysts expect this volatility to actually accelerate innovation in unexpected ways, pushing engineers toward material substitutes and more efficient chip designs that use less gallium per unit than before. Necessity has a way of speeding up research that might otherwise have taken another decade to prioritize. Whether that innovation arrives fast, enough to matter for companies struggling right now, is a much harder question to answer. The bigger lesson here goes beyond gallium itself. It's a preview of how future conflicts over technology might actually play out. Not through dramatic headlines about banned chips, but through quiet control over the obscure raw materials nobody thought to secure until it was already too late. Whoever controls those unglamorous inputs holds more leverage than most people ever realized. It's a strange kind of power, one that doesn't require aircraft carriers or trade summits to exercise. A single ministry announcement about export licenses can move markets more than most sanctions packages ever manage. And that's exactly what's been happening. With gallium, germanium, and the growing list of materials caught in this quiet standoff between two of the world's largest economies. Whatever happens next, one thing seems certain. The era of assuming raw materials will always just be there, cheap and available whenever an industry needs them, is over. Gallium proved that in the span of about a year. The only question now is which material gets caught in the next round of this standoff, and whether anyone will be ready for it this time. If this kind of deep dive into the real forces shaping the tech industry is what you're here for, make sure you're subscribed, because this story is far from finished, and the next twist could reshape the entire chip supply chain overnight. Let us know in the comments. What you think, is the West catching up fast enough, or is this dependency already too deep to fix? Either way, keep watching. Because gallium is just the beginning of this story.